adds up to in the X3 systems in particular was, besides overall performance going up again, was we really went after write performance. So historically we've gone from superlative read performance to graded mixed workloads to being able to scale up, and now we can deliver in the most write-intensive workloads in the world. 1 million IOPS write per full rack. And to give you a sense of scale, for those of you who do not have storage specs memorized, this is approximately an order of magnitude higher than the highest end SAN possibility. So this isn't a 20 or 30%, an order of magnitude. And so again, there are specialized workloads that are going to use that write performance. But the interesting thing too is now, with a mature set of products around engineered systems, the Marvell example aside, we really don't care about the workload. We can run any workload from a conventional legacy application to high-end ERP CRM, a massive big data ingest, a huge warehouse with great scan. We don't really care. And you can consolidate those applications using engineered systems with incredible results because of the combination of the performance, which you can use to tackle a big problem, but you can also use to save cost with built-in elements like storage compression, which allow you to lower your storage environment, and then also environments like the deployment time. And I'll just give you a few examples of things that we've done as far as customers and others. E-Business Suite, enormous system, many modules, extremely demanding batch and interactive workload, highly variable in terms of what customers can do. And again, we have examples just out of the box of tremendous consolidation opportunities and cost reduction of E-Business Suite and Spark Supercluster, where we combine the acceleration of the Exadata database cells and the technical capability of a fully integrated stack. For our customer recently, we did a consolidation of SAP, a large disparate SMP infrastructure, 15 servers and I don't even know how many storage devices, consolidated on a single Spark Supercluster, a 15-to-1 consolidation. But the more interesting thing to the customer was tremendous improvements in performance. So this is like a magic pill or something. We saved the customer money, we reduced their footprint significantly, we gave them something easier to manage, and their users were way happier because of the performance that they got. Turkcell, moving to high-performance warehouse, large Turkish cellular company, 10-to-1 advantage in terms of how we're able to consolidate old infrastructure. But the more interesting part of it is the performance. They compressed a 250 terabyte storage warehouse to 25 terabytes. That then reflected into their backup infrastructure and how much they had to go manage. It was just a tremendous collapse in cost. But then the performance was just incredible. They moved from what was really batch processing on many of their most important things to interactive. In fact, I was talking to a customer yesterday, and he was actually complaining because they had an old process that would actually take approximately 8 hours, and then the Exadata, it takes on the order of 8 to 12 minutes. And so at first he thought it was great, but then he's discovered that his constituent just wants to run the report all the time. So I'm sure that's what's happening in Turkcell as well, as you move from batch to real time, people then want to take advantage of things more often. Another example, moving to cloud services, Ativas is one of our customers. They provide hosted multi-tenant services around E-Business Suite and SAP, so that's their specialty. They have now moved to Supercluster as their platform and are doing a tremendous consolidation of their old infrastructure, and they're simply using a standard building block now, regardless of the customer, to deliver both SAP as well as E-Business Suite. One of the other things that goes behind the scenes on engineered systems is that because we accelerate the database so much, we offer opportunities to actually reduce your software license costs because by virtue of the fact of the efficiency, you may need a lot less infrastructure to deliver the same IOPS. And this is one thing that Ativas discovered, was deliver the multi-tenant hosting services using engineered systems, was their cost per subscriber could go down by virtue of the fact that the systems were so efficient. So deploying cloud environments are complicated. There are a set of marginally pronounceable acronyms that you have to memorize. Okay, I can say SAS and I can say PASS. I'm not sure if I'm pronounced the third one. Okay, I see Diane agrees. But the interesting thing is, in our cases, we are in the middle and think about all of this. We deliver an enormous SaaS cloud. We do platform as a service. We do infrastructure as a service. We also build all of the technologies underneath those for our customers, whether they're delivering software as a service, platform as a service, or information as a service, and infrastructure as a service. In this, the unique bit of thinking that we also bring to the table is the only company in the world that also has the primary database and the primary middleware and all the applications. For us, we're thinking holistically about those applications and application customizations and how you manage them on top of them. Now, that's obviously how we do the big picture view. The interesting thing is, the hardware guy, it's sort of amazing what customers are actually dealing with out in their environment, right? So we have a lot of great technologies around applications, but there's a lot of basic problems that we find we have to go and tackle. And recently in hardware, we acquired a company that's part of our long-term intellectual property investment strategy in networking named Zego. And Zego does a couple of interesting things. So the first interesting thing that they do is they reduce the cost of networking. And one of the interesting parts about virtualized environments is networking has become one of the biggest problems, which is you have a large number of storage and other kinds of networks, and you have a gigantic mess on your hands. So very simple idea here is reducing the cost of networking. And that's not necessarily by itself transformative, but it's one of the things that Zego can do. And it's actually quite dramatic as it's integrated with software and other capability, because we can take, and in a true enterprise complex deployment, with a large number of virtual machines and capabilities, produce dramatic savings in network infrastructure and connectivity costs. But that's not really all that we care about. Obviously, making it more efficient to connect to a network is kind of a starting point for discussion on virtualization. But the more interesting part about network virtualization is, how do I do that network connectivity? But also, how do I have the kind of infrastructure that supports true multi-tenant services and allows me to deploy and change? And in the real world, that's pretty complicated. It's pretty easy to talk about virtual machines and say, hey, you can run a bunch of stuff, and isn't this great? The real world of networking, and get to storage in a bit, is actually very complicated, especially with non-toy applications. And we don't really want to focus on toy applications. We want the real mission-critical applications. So what we're doing, obviously, is integrating these technologies as a part of an overall story. The Oracle Enterprise Manager is our management solution, not just for applications, which we've had for years, but we've also integrated it with our ability to manage hardware. So you can have an end-to-end view from a business level SLA, for example, for your CRM middleware, down to what's actually happening with hardware. The technology that we acquired from Zego allows us to then give us another interesting entry point to how we collectively manage things. I have a very simple example here. It's almost a toy example. A couple of servers running a mixture of rack and WebLogic, where I've scattered it around. And then I have what for most enterprises would be a wonderfully simple storage network. I have a few storage networks and a few Ethernets. A real enterprise has way more than this. And if you have to have connectivity to all the SANs and Ethernets and manage them through VLANs and other technology, you very quickly pull your hair out and you can't actually create real virtual environments. So what we have with the Fabric Director, and we now integrate in with our management tools, is the ability to manage Oracle RAC DB, for example, and then allocate resources and protect them in a multi-tenant environment. So for example, even though we have all these VMs on the same network, I have a secure multi-tenant environment by which this particular web logic is allowed access only to an IP net and an engineering SAN without doing VLAN configuration. Complex topologies like Oracle rack clustering and dynamically changing this on the fly are possible as well. And what we're doing is making sure you can engineer that and making sure you can manage that all from Oracle EM, so you can have a very simple infrastructure with what looks like a flat network view, and then lay on whatever network view you want for the complex enterprise architecture you have today. So we're very excited about this particular product, and it also has capabilities that we will be integrating into other products in the future to enable you to actually have a mission-critical, multi-tenant network environment that's integrated all the way up through the apps layer. Customers that use it today already have stunning results. As you can probably imagine, if you simplify and cost reduce your network layer, you can have a tremendous capability. On the performance gain that you see there from Verizon, one of the things I didn't talk about is this technology is also based on InfiniBand, which is an underlying technology we use in engineered systems. So therefore, we have a starting point fabric that's much faster than Ethernet, and that enables us to do much of the sharing. Deployment is another thing it helps with, is accelerating the deployment and allocation of resources, as well as reducing cost. Shifting gears, I want to talk a bit about storage. So the cloud actually creates a very unique set of storage demands. Historically, storage was, if you go back after decades, was pretty straightforward because most storage tended to be dedicated towards apps. And yes, you could allocate runs and things, but let's face it, you were actually buying storage that's actually tuned for particular workloads and dedicating it to those different things. The cloud is just completely different. So first of all, you don't want to do that, right? You want to have a shared multi-tenant environment on the server side, and then you want to have a dynamic shared multi-tenant on the storage side. And that creates a whole bunch of different problems. And the first problem is that we're focused on addressing is elasticity. By this I mean the ability to dynamically allocate and provision storage resources for applications. And the for applications is very important. Storage has always had the ability to just create a storage pool. That's not that interesting. What we can do is actually, with our application knowledge and our management tools, actually do the end-to-end coherence between allocating storage pools and having it properly matched in configuration on a shared storage device with the applications that want to use it, and do that on the fly. So if customers want different styles of applications in a multi-tenant environment, boom, 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 it's not the expert storage administrator to go allocate that. It's an end-to-end view on how to actually do that, and our storage devices integrate with our management tools to go and do that. The second huge thing is manageability, and manageability is a gigantic topic here, but I just want to center in on a very simple problem. By its nature, cloud storage is going to have shared applications. And by its nature, you're going to have shared servers. You can't figure out what the heck's going on. Okay? Why is something slow? Why is something fast? What's happening? You may have hundreds or thousands of users on a storage device accessed by hundreds or thousands of VMs. You can't figure it out. So one of the things that we've engineered into our storage devices is a pinpoint analytics tool that no one else has. So you can take right down to a file level, and you can say, not only what is the storage performance for this file level, but actually how does that bind to a client? What's happening with that client? And we've seen over and over and over again how customers have gone in and with this storage able to pinpoint a gnarly situation of storage performance they never could see before by virtue of the fact they had no management insight with the tools. And then finally, the ability to handle just about any workload. So, by its nature, you want to put lots of different workloads, and you actually don't know what's going to happen today and tomorrow. So we've been engineering in a huge amount of not just performance headroom, but the ability to handle, like I talked about with Exadata, any kind of workload, because you don't know what you're going to be hit with tomorrow. So